Hi everyone. In the next couple of videos I'm going to talk about how to solve trigonometric equations. So I've got a nice quick one to start off with here. Okay, we're solving sine theta equals half for theta as an element of 0 to 4 pi. So we're talking about 0 to 4 pi here. That's indicating that we need to do 2 full revolutions of the unit circle. To be able to do these questions, we need to have a good understanding of our exact values. So we should be able to know right away that for sine theta to equal half, the basic angle which is involved there is going to be pi on 6. So that indicates like sine of pi on 6 is equal to half. And that's one we actually know that solution already. So it was quite a nice one. Now what I'm going to also do here is I'm going to draw this shape. Draw this, a graph of this I should say. So a very rough sketch. Okay, there's my axes, and if the unit circle were on here, it's a sine value of half, so that means that the y value should be half. So I would probably have the line going out here somewhere. That's not quite accurate, but you know, and this y value here is going to be half. So we've turned through that angle theta. Now we can also get a y value of half if we go out the other side. So if this will let me actually draw it. If I were to draw out there, and again it would intersect the unit circle, we could still get that same y value of half. And in this case, because of the symmetry, the angle theta is actually going right there. So what I'm going to do now is I'm going to say, well, I call it the basic angle. You could call it a first quadrant angle, or you know, any sort of variation on that. So I would write the basic angle is equal to pi on 6, and again that just comes from knowing the table of exact values. That is one of my solutions. That's in the first quadrant. I need the equivalent in the second quadrant. We can see that we are going backwards from pi by that amount. So if I go pi and then backwards a bit, I'll calculate my second quadrant angle. So in the second quadrant, we would calculate it as pi minus the angle, which is pi on 6. And when we do that, a little bit of quick work with fractions, 6 pi over 6 minus pi over 6 leaves 5 pi over 6. After that, I need to go right around the unit circle again to get the other solutions. So come around here, there's 2 pi, and then add on that amount again, that angle. So when I'm back in quadrant 1 again, my next calculation would be 2 pi plus the angle, which is again pi on 6. And we do that calculation, so that's 12 pi over 6 plus pi over 6, which leaves 13 pi over 6. And if we come around here, that's actually going to be 3 pi minus the angle. So continuing our work here, 3 pi minus the angle pi on 6 gives us 18 pi on 6 minus pi on 6, which is 17 pi on 6. So what I can say is that therefore theta in this case is equal to pi on 6, 5 pi on 6, 13 pi on 6, and 17 pi on 6. There is an alternative method for working this out. So that is the solution. If you want to, what you can do is you can actually calculate the first two solutions. So in that first revolution of the circle, so the pi over 6 and the 5 pi over 6. And once you have that, add 2 pi onto each of them. If I go pi on 6 plus 2 pi, that's going to be equal to 13 pi on 6. So that gives me the next solution completely around the circle from this value. And if I add 2 pi onto this, it's going to go right around the circle again. So 5 pi on 6 plus 2 pi is going to be 17 pi on 6. So we can actually just leave that there and figure it out that way. But that's all for now, so see you later.